another type of function we want to consider is one-to-one function. Another name for a one-to-one function is injective function. Okay. Definition. A function f, we define it on the domain of f, which is a proper subset or the whole of R into R, is said to be 1 to 1 if f at x equals f at y implies that x is equal to y for all x and y in the domain of f. Equivalently, yes, f is 1 to 1 if anytime x is not y, it means f at x is not the same thing as f at y for all x and all y in the domain of f. So any function that behaves like this is called a one-to-one function. Precisely what we mean. It says that f is 1 to 1 if the image or the images of 2 points are the same, means that those 2 points are the same. Said another way, if you have 2 different elements of the domain of the function, then their images must be different. A function that behaves like that is called a one-to-one function. Notice that we have seen an example of a function for which you have 2 different elements of the images, of the domain, but they produce the same image. So a function of that kind is not a one-to-one function. Let us give examples. Let's consider the function f. We define it on R into R. F of x is equal to x plus 1. So what this function does is for any value given, it adds 1 to it to produce its image. Now, suppose then, so we want to show that f is 1 to 1. That's the question. All right. To solve this problem, we appeal to the definition of one-to-one function, which says f at x is equal to x at y, implies that f of x must be equal to, so it says if f of x is equal to f at y, it means x must be equal to y. So we need to first assume, so we assume f of x is equal to f of y for arbitrary x, y in R. So our goal is to show that x must be equal to y. To do this, f of x equal to f of y, what does it mean? That's to say that x plus 1 is equal to y plus 1. For any arbitrary x and y, we can find in R. That is for arbitrary 2 real numbers we call x and y. If this is true, if x plus y is equal to, if x plus 1 rather is equal to y plus 1, what does it mean? This means that x plus 1 minus y plus 1 is equal to 0. Just take this to the other side of the equality. And if we open this, it means again that x plus 1 minus y minus 1 is equal to 0. And if this happens, it means also that x minus y is equal to 0, because 1 minus 1 will go. And what does this mean further? This further means that x is equal to y. So what have we done? We have shown that f of x equal to f of y implies that x is equal to y, which satisfies the definition of one-to-one function. Therefore, the function f, which we define like this, is a one-to-one function. I hope this is clear. Yeah. Let me take an example of a function that is not one-to-one. So the two examples will now help us to tackle other problems that may come regarding one-to-one function. So let's take f from R into R. Definition is this. F of x is equal to x squared. Good. The question is f one-to-one? Is f one-to-one? To solve this problem, it suffices to check whether this function satisfies the definition of one-to-one function. Or we try to produce, if it does not satisfy it, can we produce counterexample? That means, can we produce specific two elements of this set R such that they are different, but their images are the same? If we're able to produce such elements, is a way to disprove that this function is not one-to-one. Or we can go direct to check whether it satisfies the definition of one-to-one function. If it does not satisfy that definition, it is also a way to show that this function is not one-to-one. So I quickly do one of them while we check the remaining one. Look, suppose f of x is equal to f of y for any x and any y in R. What does this mean? This means x squared is equal to y squared for all x and all y in the set of real numbers. Alright. If x squared is equal to y squared, we ask ourselves, what does it mean? Does it mean that x is equal to y? The answer is no. For example, but this does not mean that x is equal to y. For instance, if we take x to be negative 4 and take y to be 4, then x squared is equal to y squared. But then x is different from y. Hence, what we have seen is that we saw that f at x is equal to f of y, but x is not equal to y. So f of x is equal to f of y, but x is not equal to y. Hence, our conclusion is this. F is not 1, 2. So this is an example of a function that is not 1, 2.